Good morning to all. Myself, Professor T.M. Divakar, working as an assistant professor in ENTC department in Sharad Institute of Technology, College of Engineering, Ichirakanji. So today we are going to cover one more semiconductor devices, that is a BJT, Bipolar Junction Transistor. In the previous video we studied about the diode. So next semiconductor device is a BJT. So today we are going to cover this BJT. So bipolar junction transistors, it is a semiconductor device and it is constructed with three regions, and these three regions are doped regions. So these regions essentially form two back-to-back PN junctions in the same block of semiconductor material, that is silicon material. So most common use of BJT is in linear amplifier circuit. So what exactly the linear? Linear means that the output is proportional to the input. So it can also be used as a switch. So for example, in logic circuits we have used transistor as a switch. So there are mainly two applications of the transistors. One is amplification purpose, and second one is it is used as a switch. So this is the understanding of the BJT. So transistor having the three terminals. One is the base, emitter, and the collector. So base is the main terminal. Base is also called as it is controller terminal. So we have to apply any inputs to the base, and at collector we get the output. So this is the main function of the transistor. So by general diagram, for understanding purpose of working of BJT, we have shown here the diagram. See here, at the base we are applying the inputs, and at collector we get the flow of electrons, means we get the output through the emitter. So this is the symbol of the transistor. There are three terminals: base, emitter, and collector. So there are two types of transistors. One is NPN transistor and second one is the PNP transistors. So this is the symbol of the NPN and PNP transistors. So both these transistors are formed by joining two diodes back to back. So see in the first diagram. So this is the diagram, first diagram. In that we have connected. So this is the diode. This is one diode and this is another diode. So we have connected here two diodes back to back. Means we have connected anode to anode. So when we connect two diodes anode to anode, we get the NPN transistor. Here it is in the second diagram. See here, second diagram, we have connected two PN junction diodes with two cathodes. So when two cathodes connected back to back, we get the PNP transistor here. So this is the symbol of transistor. This is the symbol of PNP transistor, and this is the symbol of NPN transistor. So both the symbols are looking similar, but there are some identification. There are some mark how to identify the PNP and NPN transistor. So see, this is the arrow mark which is present on the emitter terminal. If this arrow mark is outward directions, so in this diagram or is in this figure, this arrow mark is going outward directions. So this is called as a NPN transistor. This is the symbol of NPN transistor. And this see in the second figure, that is the second symbol. In this figure, the arrow mark is in the inward directions. So this symbol indicates the PNP transistors. So this is the qualitative basis operation of the BJT. So BJT consists of two back-to-back PN junctions. So the middle region is the base one, and it is very thin region. The three regions are emitter, base, and collector. So carriers are injected, that is emitted into the base from the emitter. Okay, since the base is thin, most of the carriers injected into the base diffuse into the collectors because of the base is thin. So what does thin base thickness means? The base thickness is much thinner than the diffusion length of the carriers which is injected from the emitters. So see, this is the construction of the NPN and PNP transistor. Okay, in the first diagram, see, this is the PNP symbol. This is the PNP. PNP, that is the emitter, base, and collector. Okay, so two diodes are connected cathode to cathode, so we get the PNP transistor. Here it is a construction of the NPN transistor in the second diagram. So this is the NPN. Okay, these are the three terminals: emitter, base, and collector. So in these constructions, we have connected two diodes with anode back to back. So let us see the currents and voltages in transistor. As I said that the arrow mark which is indicating on the emitter, that considered whether it is NPN or PNP transistors. So this arrow mark which is on emitter terminal, it is in the inward direction, so this is the PNP transistor. And see this arrow mark which is on emitter terminal, it is outward directions, it is indicating that it is a NPN transistor. So let us see the current and voltages in PNP and NPN transistor. So see, this is the phi B, means this is the voltage across terminal, base, and emitter. Here in this case, the emitter is positive with respect to terminal, with respect to base, which is negative. So voltage between the terminal, base, and collector is VCB, and the voltage between terminal, emitter, and collector is VEC. So what are the currents? So there are three currents flowing, that is IE, that is a current through emitter terminal, that is called as IE terminal. So this current is always with the arrow direction. Next one, the current through base is called as a IB current, base current, and current through terminal C is called as a IC terminal, IC, that is the collector current. So these are the currents and voltages of BJT and of BJT. or PNP and NPN transistor. So the direction of the current is always prepared with the standard equations, because there is a relation between the currents in base, collector and collector, emitter and collector, that is IE is equals to IB plus IC. So suppose if the emitter current is coming in our directions, so both the currents IB and IC going outward directions, because IE is equals to IB plus IC. That is happening in PNP transistor. See, this is the direction of current IE, it is coming inside. So the direction of IB and direction of IC is going outward. And in NPN transistor, see here, the direction of current of IE is going outward directions. So this is the outward direction. So that's why the direction of current of IB and IC, it is coming inside. So this is coming inside. See here, because of the relation IE is equals to IB plus IC. Okay, so this is the current flow conventionals. As I told you now, this is IE is going outside. See here, IE is going outside, so IB and IC, it is coming inside. The NPN BJT structure. The emitter E is heavily doped N type. The collector C is also doped N type. Doping means what? Doping is the process of adding the impurities to the semiconductor. It is nothing but a doping. Heavily doped means we have to add, or there is a high proportion of impurities added, so it is called as heavily doped. Lightly doped means there is the proportion of adding the impurities less, that is lightly doped. So this is called as heavily doped and lightly doped. So in NPN transistor, the base is lightly doped with positive type to the emitter and collector, means P type in the NPN transistor. So the base is physically very thin for this region. So in NPN and PNP transistors, or in a transistors, there are two junctions available. One junction is called as a B junction and another junction is called as a CB junctions. Means the PN junction joining the base and emitter regions is called as a base emitter junction, or the PN junction joining the emitter, or the PN junction between the base and collector region is called as a collector base region. This is called as a base collector region, and second one is called as a emitter base junction. So this is the operation of the BJT. Let us see. So terminal, this is the terminal emitter, three terminals emitter, this is the base and this is the collector. So the forward bias between the base and emitter injects the electrons from emitter into the base, and the holes from the base into the emitter. So in the forward bias condition, the base and emitter injects the electrons and holes. So as the emitter is heavily doped and the base is lightly doped, most of the current transport across this junction is due to the electrons flowing from the emitter to the base. Next one, the base is lightly doped and physically it is very thin, thus only the small percentage of electrons flowing across the base and emitter junctions combined with the available holes in these regions. most of the electrons, that is fractions which is approximately to 1, for example 0.98, flowing from emitter into the base and reach the collector base junctions, and once they reach this junction they are pulled across the reverse bias CB junction into the collector region and they are collected. So those electrons that do recombine in the base gives rise to a small base current. Okay, next one, the electrons collected from the collector at the CB junction essentially form the collector current in the external circuit. So there will be a small contribution to the collector current called as a ICO from the reverse saturation current across the CB junction. Next one, the base current supplies the positive charge to neutralize the electrons recombining in the base. This prevents the buildup of charge which would hinder the current flow. Let us see the biasing of the transistors. So already I told you what is biasing. Biasing is the process of applying the external voltage to the transistors. So like this we have the three configurations of the transistors. One is a common emitter configuration, second one is a common base configuration, third one is a common collector configurations. Why the name has given common, I will explain one by one. So before that I will tell you the definition of these three configurations. In this example we have considered the PNP transistors. You can same design with the PNP also. So for the understanding we have considered here NPN transistor. See, this is the NPN transistors. See, I told you how to identify the transistors because the arrow mark which is on a emitter terminal is going outward, so it can indicate this is the NPN transistors. So in these three configurations we have used the NPN transistor here. So in this first figure, this is the common emitter configurations. So why the name has given common and why it is saying the emitter? Okay, we see there are three terminals: base, emitter and collector. Okay, so emitter, see here, the input is applied between the terminal B and E, means the terminal base and emitter, and the output is taken from the collector and emitter. So in both input and output the emitter is a common terminal and hence the name has given the common emitter configurations. Means we have to apply the input at base and emitter and we have to collect the output from collector and emitter. So in both input port and output port emitter is a common terminal and hence the name has given a common emitter configuration. The same definition you can consider for common base. See here, so there are two parts. This is the input part, this is the input port, this is the output port. So input is applied between the base and emitter and the output is taken from base and collector. So base is the common terminal between the input port and output port and hence the name has given a common base configuration in this diagram. So let us come to the common collector configuration. The definition is same, you can follow, because the input is the input is applied between the base and collector and the output is taken from emitter and collector. So collector is the common terminal between the input and output and hence the name has given common collector configurations. Okay, so these are the transistor configurations. Okay, so let us I will explain in details by taking the common emitter configuration. So this is the practical circuit diagram of obtaining the characteristics of NPN transistors, considering here common emitter configurations. Common emitter means already I told you that emitter is the common terminal between the base and emitter and collector and emitter. See here, while doing or while obtaining the characteristics, we should know the input current, input voltage, output current, output voltage. These four parameters we must needed. So for this, see here, to calculate the current IB, that is the, here IB is the input current and VB is the input voltage and VC is the output voltage and IC is the output current. So we have used the voltmeter to measure the voltage, and we have used ammeter to measure the current. So see here, the IB input current we have measured in microampere. It is given that it is a microampere, and the output current IC is measured in milliamperes. Okay, so for measuring the voltage VB, we have used here voltmeter. This is the VB, this is voltmeter VB. This is another voltmeter VC we have used to measure the voltage between the terminal collector and emitter. Okay, so this is VBB is a base to base supply voltage, the main supply voltage. This is VC is nothing but a collector to collector supply voltage. Okay, so there are two characteristics, one is the input characteristics and second one is the output characteristics. So in this diagram we have shown the input characteristics. So input characteristic is, it is a graph of input current versus input voltage. So in this diagram the input current is IB and input voltage is VB, and the output here and the output voltage kept constant. Okay, so this is the input characteristics. So what is the definition of the input characteristics? It is a graph of input current versus input voltage and output voltage kept constant. See here, in this diagram VC, VC1, VC2 and VC3, these are the three different iterations we have considered here. Means you can kept the output voltage at one value, okay, and you can calculate, you can increase the input voltage, accordingly that the current will increase. So this is the one graph. See here, next iteration means what, again you can consider one value for VC, that is you can keep that output voltage constant, that is VC2, means you can consider another value, that means you can keep at 5 volt or 10 volt or 20 volt, anything, but it should be remains constant. Again you can increase the input voltage, okay, according to that input current will increase. So this is the second graph. So this is the second graph. See, this is the second graph. VC is the second graph. Means, see here, so for different, these three different values of VC, we are getting the different values, or there is a values between the input voltage and input current. So from this characteristics we can find out the input resistance. That input resistance means what, it is a delta VB upon delta IB at a constant of VC as per the, according to the diagram, that is the input resistance, that is RI. So it is the ratio of change in voltage into the change in input current. Okay, so next one is the output characteristics. See, output character, how we can find out the output characteristics. So it is a graph of output current versus output voltage and input current kept constants. Listen carefully. Output characteristics means it is a graph of output current versus output voltage. Here output current is IC, which is measured in milliampere, and output voltage is VC, which is measured in volt. And see here, IB is a input current, and we have kept this is a constants. So IB means 50 microampere, IB is 100 microampere, IB is 150 microampere, IB is 200 microampere. These are four different values. We have kept the constant value, and then means while calculating the output characteristics, we always remember that the input current should be a constant at one value, and you can take the readings. That means you can increase the output voltage, the output current will also increase. So in this output characteristics, there are three different regions available. One is the cutoff region, second one is the active region, and third one is the saturation region, as in the diagram it is showing that. Okay, so let us see what is the cutoff region. So in this cutoff region, both there are already we know that there are two junctions available. One is the emitter based junction and second one is the collector based junctions. So both are reverse bias, means there is no input current and there is no output current. Okay, second one is the active region. In that active region, the emitter base means B junction is forward bias and collector base junction is reverse bias. Okay, so in this case, so the output current, that is IC, increases slightly with increase in a VC. Means in active region, the output voltage, if you increase the output voltage, that is VC is the output voltage, the IC will also increase slightly, and largely it is depends upon the input current. Okay, the next one is the saturation region. So in this region, both the junctions, that is the emitter base junctions and collector base junctions, both are forward bias. So in this case, the output current increases rapidly with increase in a output voltage. Okay, so what is the output resistance here? It is also called as the dynamic output resistance, that is R out, R0 output resistance, and it can be defined as a change in output current, output voltage upon the change in output current, that is a change in delta VC upon change in delta IC at a constant IB. So this is the input and output characteristics of the common emitter configurations, which is considered for the NPN transistors. You can also design same with the PNP transistors. Thank you. In the next lecture, we come to common base and common collector configurations. So thank you.